Welcome to the video, my fellow Goofy Goobers. Today I'm going to learn you a thing or two about how you can import a fully animated game asset sprite into Godot. Then, after we're finished importing this goober into Godot, I will teach you guys what component-based design is, what its benefits are, and why you should be using it, because if you're not using it, you're just a dummy head. And I will also show you my process for how I build my components and then use them to turn this goober from a sprite into a fully functioning enemy within my game. So, let's get right to it. Alright, so I've headed back into my Godot project here, and I'm going to show you the tool that we will be using to import the animated sprite from Aseprite into Godot. Now, the first thing you're going to want to make sure is that this asset library tab up here at the top is, existing. If it doesn't exist for you, it's really simple. All you have to do is go over to the editor tab and then click on Manage Editor Features, and you'll see this little asset library staring back at you with its big, beady, lifeless eyes. Make sure that checkbox is enabled, or the asset library will be very angry with you. So, once you've enabled that checkbox, then you can go ahead and head into your asset library and look up Aseprite. So, let's do a little bit of typing here. Here we go. We've got a couple of options that pop up, but the one we're going to be using is the Aseprite wizard. So go ahead and click on that and download this bad boy. And once you're finished downloading it, let's do a couple of extra things because the Aseprite wizard needs a couple of configuration options set before we can actually use it properly. One of those first things we have to do involves opening the project and going into project settings. Here, you're going to want to navigate to your plugins tab, and then you'll see there's probably going to be just the Aseprite wizard, and if there's more, don't worry about it, it's fine. Go ahead and make sure that Aseprite wizard is enabled. And once you've done that, there's one last thing we have to do. So let's go back into our project tab and go to Tools, and under this little Tools tab here, you're going to want to open the Aseprite wizard configuration. And all this is asking for is a path to the Aseprite executable, the .exe file. And depending on how you downloaded it, it could be in some different places. So if you downloaded it not on Steam, chances are it's probably going to be in your program files under the Aseprite folder. And if you downloaded it from Steam, then it's probably going to be in your Steam Apps folder. So go ahead and do a little bit of snooping around on your computer, and once you find that executable, do some Control-C and Control-V magic and copy and paste the file path into this little tab here. And after you're done with that, click the test button to make sure that the Aseprite wizard can find it. And if it gives you this message saying it's found, then you've done a good job. If you didn't, I'm really disappointed in you. Anyways, close that window, and that's actually it. We're ready to go ahead and start importing this guy. So let's get to it. Alright, so now that we're done setting up the Aseprite wizard, let's go ahead and create a basic scene for our enemy. So let's create a new scene, and I'm going to be using a root node type of character body 2D. And we're going to have to add a couple of things here for the Aseprite wizard to properly import this guy into Godot, and we're going to have to add two nodes. The first node we're going to have to add is the sprite 2D node, and this is where the sprite for the enemy is going to be stored in. It's going to be stored in this file, obviously. And the next thing we're going to want to do is instantiate an animation player into this scene. And make sure that both of these nodes are children of the character body 2D and they aren't nested in one another. After we're done doing that, click on the Sprite 2D node and head over to the Inspector tab and scroll all the way down to the bottom. You'll notice that there are a couple of extra options that were not there before. These options are for the Aseprite wizard. And we're gonna have to set a couple of things up for it. Select the animation player. All this is saying is that we want to import all of the animations from the Aseprite file into this animation player we added. The next thing we're going to have to do is get a file path to the Aseprite file we're trying to import. For me, I've already been to that folder plenty of times, so it pops up in my recent tab, but you're probably going to have to look around on your computer and navigate the file system. But once you've found the Aseprite file, make sure you select the correct one and then go ahead and open it. And now that you have the file path selected for that Aseprite file, the last thing we're going to have to do is make sure the Only Visibles Layers button is toggled. And I'll show you why this is important here in the Aseprite file. So when I had first displayed this in the intro, you saw that there was a background and a shadow. Now, the background you definitely do not want in your game because that is going to be attached to the sprite and only the sprite, and it's going to look really wonky with a separate background behind the character himself. You don't want that. So what that Only Visible Layers toggle does is when you hide these layers in the Aseprite file, they won't get imported with the rest of them. So make sure that you have all of these layers separate so that the Aseprite wizard can properly import this the way you want it to. And once you've gotten all the layers selected that you want, another thing to double check is make sure all of your animations are separated in their separate tags and loops. So you can see that the running animation is in its own little loop here, and this is basically just separating the animations from one another so that the Aseprite wizard will be able to import them separately, because you don't want them imported all into one giant animation, you want them separate. So once you've made sure all of that stuff is set up, you're ready to go ahead and go import this guy. So let's head over to our Godot project here. And before we import this guy, I've made this mistake already, is you want to save the scene before you import. Otherwise, it's not going to work because it won't be able to find the Sprite 2D because you haven't saved it yet. So go ahead and save this scene in whatever folder you need. Since I've already created this enemy, I'm just going to store this one in the examples folder and then just click save. So once you've done that, you're now ready to go ahead and import this guy. And all you have to do is click the import button. And it might take a second, but once it's done, you can see that this guy, he's actually in Godot now. It worked. He exists and he looks like a little goober. He's just standing there and he looks dumb. Just look at him. But that's pretty much it. You've successfully imported a sprite from Aseprite into Godot. And if you head over to your animation player, you can see that all of the animations have been imported properly and the dude is fully functioning, looking all nice and stuff. And all of these animations are separated by their tags and they have their proper names, and you're good to go. One last thing to note though is that all of the animations by default are looping, and say for the death animation you really only want that to play once. And to make sure that this isn't looping for this specific animation, just go ahead and click this button here twice and it should only play once now. And do that with any animation that you see fit and you should be good to go. What the hell even is composition? What does it mean, Goob? Well, you've come to the right place, my friendo comprendo. Let me enlighten you on what component-based design even is. So, let's say you are an inheritant soy boy. And since you're an inheritant soy boy, to add an entity to your game, you would just have to create an entity class with the proper functionalities such as health, attack, hitboxes to receive damage, and velocity for movement. Now, this is all fine and dandy, right? Just create a class, all of your entities inherit from it, you don't have to create duplicate code for those entities. What's the problem, Goob? Well, you ignorant swine, you also want to create a tower in your tower defense game. And tough cookies, my friend. You're gonna have to create another class just to reuse some functionality, because the tower cannot inherit from the entity class because it doesn't move, right? And if it were to inherit from the entity class, it would inherit velocity. And we don't want any of that to be a part of the tower, because we don't want this tower to move. We want it to sit in place and just worry about attacking things and then receiving damage. So, you're just going to have to create another class just to add something else to your game. And again, you might be saying, well, I mean, it's just 2 classes. It's not really a big deal, right? Well, there's even more. As Billy Mays used to say, but wait, there's more. There's objects in your game. So now you have to repeat yourself again and create another class. And this is just adding 3 simple things into your game that all have some specific piece of functionality reused throughout these classes. And you can see how this can get out of hand and tedious really quickly. So now you gotta be asking, there's gotta be a better way to go about this instead of repeating yourself over and over again like that schizophrenic homeless man at my local Arby's. That is where composition-based design comes into play. So, let's say you have a health, hitbox, and a velocity component, right? You have these 3 pieces of code and functionality that you want to reuse throughout your game. So the component-based design GigaChad would say, well, I'm just going to create a health component that only worries about tracking health. It doesn't do anything else that isn't related to health, it just worries about health. And then now they want to create a hitbox, and they want to reuse this throughout their game for entities, towers, and objects. So, as they did with the health component, just create all of the code and functionality that's related to hitboxes and receiving damage, and that's all it worries about. It doesn't worry about anything else. So on and so forth until you have all of these Lego pieces, these components, that you can then reuse throughout your code. So this sounds amazing, right? All you have to do now is mix and match these to your heart's desire. So if you want to create that entity from before, just reach into your Lego bag and grab the health component, the velocity component, the hitbox component, all the related stuff, and then just put them together. Same thing with the tower. Reach into the Lego bag, reuse these things. You don't have to worry about creating another class, having to retype all of this specific code because it's from a different class. It's just reaching into your bag of magic, putting it together, and then it just works. And this is beautiful because this means that you can build so many different things with just these Legos alone, right? You know how dynamic and how many things you can build with Legos themselves. That's literally what component-based design is. And it is a beautiful thing to see in practice. So let's actually go practice this and build our enemy from our game. So thanks for coming to my TED Talk. So now that we are back in our Godot project, you'll soon begin to notice that we've kind of already been using composition this entire time as we've been making this enemy up until this point. You can see that we've attached specific pieces of functionality to this guy through the use of Godot nodes. And you'll notice also that the animation player and the Sprite 2D only focus on their specific niches of functionality. So it has all of their properties and methods that are attached to what a Sprite 2D is, and the animation player only has things related to what an animation player is, right? And that is really the whole philosophy and principle behind component-based design. It is creating reusable pieces of code that are related to a specific piece of functionality that you can reuse throughout your game. So let's start off with something simple, such as the health component. So let's say you were to create the health component from scratch. all you would really have to do is just create a new scene and give it a root type of node or node 2D, depending on what you want, right? It doesn't really matter at this point in time for the health component specifically, so you would just create, base type node, you would name it properly, and then you would save it into your file scene, or to your files, and, name it accordingly. But since I've already done this, I won't be doing this again, but that's really the whole, how you make a component, right? You just create the scene, create the root node, attach a script to it, and call it a day. So in the finished health component that I have created here, let's open up that script and go through the important parts of it, right? I won't be describing too much how I coded the health to work. The main takeaways you should be focused on is what a component is, how the component works, and how that component can communicate with other components. And that's what I'm mainly going to be focusing on here. So you can kind of ignore most of this here, except for a couple of lines, but we'll get into that in a second. So the first thing you're going to notice is that we have given this a class name. And the reason being is that Godot has no inherent idea of what a health component is or what defines it, right? So we have to tell Godot specifically that this is a health component, and we can do that through the use of class names. And this is important because when we reference this later on in a different script, this Godot will not, give us the IntelliSense on what all of these properties are. So if you don't know what IntelliSense is when you're referencing something in Godot, it recommends you specific things. And since we are in the health component already in this specific script, when we reference the script itself, you can see Godot recommends the variables such as current health, the signals such as dead, damaged, and healed, and all of the other methods related to it, like the damage method, right? And when we give this a class name health component, when we reference this later on in other scripts, it will tell us all of that stuff. So Godot will know what we're talking about. So that's one important part of this. The next thing is that you'll notice that these signals are for communication between different components. And the reason being is that the game doesn't know when the health has reached 0, right? And the way we're going to communicate with the rest of the game outside of this health component is through the use of this signal here. Now you can call the signal by using the keyword signal, and then what you need to do to emit that signal is call the emit method on that signal. After that, the final important part here is the export keyword and exporting variables. So what this basically means is if you click on this health component in the editor and you have an exported variable, such as max health in this case, you'll notice that in the editor in the inspector tab, there is a value labeled max health. And the reason that this is extremely important is that if we add this health component to our enemy here, which we're actually going to go ahead and do right now. So let's go ahead and look up our health component scene and then add it to our guy. So you'll notice again that the max health is here in the inspector tab. And the cool thing about this is that you can then set this variable to be whatever you need it to be depending on the type of enemy you're making. So let's go over here to this other enemy I created, the Dark Flame, and you'll see that his health component, he has 100 health. And exported variables allow you to change health change a value on a case-by-case basis depending on what enemy you're adding to your game, so that all of your enemies will have different healths that you can set dynamically. Now, if you were to not export this variable and you were to set it inside of the script and you set it to like 10, then all enemies throughout your game will have the same amount of health. And that is not good unless you intend to do that, but I'm assuming that usually is not the case. So those are basically the main principles of the important parts of component-based design when creating your own component. So remember those things. Now, let's say we want to add another component. So we want our guy to move. So let's give him a velocity component. So I've already created all of these components, by the way, and I'm just demonstrating what they look like and how they're going to be hooked up. So in this velocity component, you can see that it has more or less the same reoccurring theme, right? The class name, the exported variables to change on a case-by-case basis, and then the specific functionality that only handles velocity, right? And that's pretty much it, right? You just code the specific functionality for what you want this component to do. In this case, it is velocity. And all of these functions handle that, right? And here in this scene tree, all we're going to do is give this guy a basic movement speed. So let's just give him a movement speed of like, I don't know, 250. That's too fast. We'll say like, I don't know, 120. And then the acceleration is 20. There we go. We've set the values, and now we are referencing the code from the velocity component. Right? Now, at the start, it's not doing anything just yet, and we'll get to that, but let's go ahead and finish adding all of the components necessary. So, let's go ahead and add a hitbox component because we want our enemy to receive damage. So, the first thing you'll notice when we add this, or when you create a hitbox component, is the one that I've made is an area 2D. And this brings up an important point that you don't have to use the base node type for all of your components. Your components can actually be any kind of node that you want. So if I were to go way off into an example completely different from here and say you created a button component for your game UI, that is a valid component and you reuse that button through your UI, right? I'm just throwing out an example here. Point is that components can be made of whatever you want them to be, right? And just be adding on functionality to a node that already exists. So in this hitbox component script, it's pretty simple as far as everything's concerned. And you can notice that it does have all of the same reoccurring things: exported variables, hitbox component, class name. And one other thing to note is that it asks for a health component. And the reason being is that we want to call we want to call the damage function on the health component, and we want to tell how much damage is taken, right? The hitbox detects when damage is taken, and then we tell the health component that it is receiving damage. And you can see that we are asking specifically for a health component, right? And we're not setting it in this scene because then all enemies would have the same health component. Right? What you want to do is when you add this in is you want to assign it the health component you've added for this specific enemy. So all you would have to do is click the assign and then click on the health component there. And there you go, the health component is assigned. And another thing you will notice as well is that this area 2D is asking for a collision shape so that it can actually have an area to reference to. So let's go ahead and do that. Now your first instinct would probably be to go to the hitbox component scene and then give it the collision shape 2D here, which is not good. The reason being is that all enemies are going to have a hitbox component, and if you give it a specific shape inside of this scene, when we add this scene to the enemy, they're going to end up having the same shape of the hitbox. And I can tell you right now, probably all your enemies in the game are not going to have the same hitbox. If that's the case, go ahead and do that. But otherwise, what you want to do is you want to make sure that you do not add it inside of the scene, and you instead add it inside of this character right here, right? So we add that collision shape 2D here, and I will be calling this hitbox because that's how I like naming things. You don't have to, but I like doing it. So you get the idea behind components now, right? So let's add the last few things we need this enemy to do. So I also have an attack component here that, handles attacks. So this will handle attacking. It is another area 2D, so it is going to need a shape for it, and we're going to call this attack shape. And you'll also notice, I forgot to mention, that I am asking for a reference to the shapes for these. This is specific for how I've coded the functionality of the hitbox and the area or the attack component. So, you don't have to do it like I'm doing it, right? This is just specific for my game, and this is the best way I could do it for my game, right? Your game could be different. What I want you to focus on is what are the principles of these components, right? what do you do to create them, right? You have the signals, you have the class names, you have the exported variables. I just want you to get the idea behind them, the components as a whole, right? This is just an example, so take it as such. And what we're going to do here is just give it a shape here. So when he attacks, see what the shape of that is. We'll just kind of conform to it. And then he attacks again, and that's fine. It's no big deal there. Let's also add an attack range component. Right here, it is another area 2D. If you couldn't tell, I really love my area 2Ds. So let's go ahead and give this guy a collision shape 2D here. And that should be it. That is all of the functionality that I will be adding to this enemy at the moment. Just attack range, attack, hitbox, velocity, and health. So now that we have all of our components set up and added to our enemy scene, we need to bring these together through the use of a script that we're going to attach to the root node. So let's go ahead and add a script using this add script button up here and then creating it right here. So the first thing you're going to have to do is grab a reference to all of the nodes and components that you need to grab. In my case, I'm going to grab all of these components and the animation player. So an easy way to do this is to hold down Control and select all of these components, and then on the last one, click and hold, and then you can drag these into your script and then drop them as such. That way, you can avoid a little bit of typing and save your fingers from breaking. So the next thing we're going to have to do after that is instantiate these components using our class names that we created. This way Godot will know what we are talking about. So all we have to do is say we want to instantiate this attack range component as an attack range component. And I'm going to go ahead and do this for all of these components. Alright, so now that Godot knows what the hell we're talking about, I'm going to go ahead and copy and paste all of the code that I've already written for this enemy to save y'all a little bit of time. Now, I'm still going to go over the important parts that you need to take away from this, and it's really only going to come down to two things: connecting to the signals from the components that you want to connect to, and then creating functions for those signals to call whenever the signals are emitted. So what you would have to do is grab the component that you want to connect to, ask for this proper signal, so you would call the health component and then grab the correct signal from the IntelliSense, and then you would call the connect method on that signal. And what the connect method asks for is a reference to the function that it's going to call whenever the signal is emitted. And it's important to make sure that when you pass in this reference that you do not have the parentheses on the end of the function like this. It's really important, otherwise it will not work. So after we've connected to that signal and we passed in a reference to the function that we want to call, let's go ahead and check out what we're actually doing in this onDead function. And as you can tell, it's really simple. All I'm doing is referencing all of the components I need to, and then calling the specific lines of code that I want to be run. So, for example, on the velocity component, whenever the enemy dies, I obviously want them to stop moving because they're dead. So I call the stop moving function on the velocity component I created. And this is where good naming conventions come into play. If you have bad naming conventions and these function names aren't clear on what they're doing, you're going to get yourself confused on what's actually happening inside of these components. And you're going to waste time going back and forth trying to see, okay, so this function does that and I want that function to do that. What you want to do is just make sure that all of your names are really obvious for what they do, so that when you come into the script, it's really simple to just call the right method on these. And that's pretty much the whole thing that you have to do, just rinse and repeat for all of these signals that you have to do. So in my case, the start attacking signal and the stop attacking signal I need to connect to, because I want to have him stop moving and start moving based on whether or not he is attacking. And that's pretty much it. Besides playing the correct animations from the animation player, I mean, this is all as simple and as straightforward as it can get. And that is the power of component-based design and composition in Godot. I'll see you in the outro. And that just about covers it for this tutorial. I really hope I helped you guys out and you've learned a bunch of things from watching this video. And if you're curious about any of the assets used here, I will leave a link down below to the guy who created them. Go out there and support him. He has inspired me for plenty of my own pixel art endeavors, and he makes high quality assets. And if you're curious about following me and any more of my content, I have links to my socials and my newsletter down below. And in my newsletter, I cover educational content pertaining to pixel art animation, game development, and Godot, as well as various other topics. Links to all of that are down below, and I hope you guys have an absolutely wonderful day. I'll see y'all next time, Goofy Goobers. Peace out.